A previous concept we have been learnt about relations, types of relations, and the next concept we have been learnt functions and types of functions. So now let us learn about the problems to the entire of the journey. So according to the given condition here, so what they have been given, you have to determine whether each of the following relation is reflexive, transitive and symmetric. It is true or not. The first question says, relation R in the set A is up to, what is the set they have been given? Up to 1 to 14 elements are there. So defined as R is equal to x comma y such that 3x minus y is equal to 0. Isn't it? So according to this condition, so what are the conditions we know? That is the property holds. Which are the property here? Property are, or the conditions are, first one, reflexive. We need to prove whether it is a reflexive or not. So what is the condition for reflexive? Again it says that A comma A belongs to R for all A belongs to A. Means what? The set of given all the elements should have its own reflexive. Then only we can call it as it is a reflexive condition. Second condition is symmetric. So what does the symmetric condition says? Symmetric condition says for all A comma B belongs to R, this implies B comma A also belongs to R. This is the second condition. So what is the third condition here? Transitive. So what does the transitive condition says? Transitive condition says has A comma B belongs to R, then B comma C also belongs to R. This implies the condition of A comma C also belongs to R. This is the condition. So please do kindly remember these three conditions. We will be solving for the entire problems. So first condition is reflexive, second condition is symmetric and the third condition is transitive. So what is the condition? What is the question that have been asked here? The relation R in the set A is equal to 1 to 14 elements. Define on the relation. What is the relation? You have to find the ordered pairs which is related to this A set. So what is the condition here? 3x minus y equals to 0. First we need to find if each and every ordered pairs are belonging to R means we need to find the rth elements. So what are the rth elements? Let us see. Rth elements are R is equal to. So what is the condition here? Write down x minus y such that 3x minus y equals to 0. So when you are applying the input only, you will get the output values. So here what happens? 3x minus y. You can apply for the x values. What about the y values? So what you have to do? Simplify this equation. So how do you simplify it? That is 3x minus y equals to 0. This implies 3x equals to y. So what is the condition we have been got simply as R is equal to 3x minus y. Apply the elements of x and find the values of y. So very simple, as you know, when x equals to 1. So what happens to the y value? Y will change to 3. When x equals to 2, it will change to 6. Now how do you write it in an ordered pairs? So you can simply write the ordered pairs as R is equal to x comma 1, that is 1 comma 3, next 2 comma 6, next 3 comma 9, next 4 comma 12. Is it possible? 5 comma 15? No, which is not at all possible because the elements are 1 to 14 elements. Both x and y should be present between 1 to 14 only. So, according to this condition, we cannot apply x equals to 5 so that the y elements would be 15. So, we have got the R elements. Then how can I apply it for the reflexive? So, what does the reflexive condition says? The reflexive condition says R equals to A comma A should belongs to R for every A belongs to A. The first condition means if here the 8th element is 1, then the reflection should be 1 also. So, is that possible over here for the given rth element? No. Here what happens? Reflexive condition fails. Reflexive for all A comma A belongs to R for every A belongs to A, but we cannot find the values of 1 comma 1 does not belongs to R. Hence it is not a reflexive. Not a reflexive. It is not a reflexive. Next, let us prove for the second one. So, what does it says for second one? Symmetric condition. So, what does the symmetric condition says here? Symmetric says for every A comma B belongs to R, then B comma A also should be belongs to R. Right, let us check. Let us assume A is equal to 1 and B is equals to 3. The first element, what we have got? 1 comma 3. Is this 1 comma 3 is belonging to the set R? Yes, the 1 comma 3 ordered pair is belonging to set R. Now, A comma B is belonging to R. Now, check. Is 3 comma 1 is present in R? No. So, therefore, we can directly write it as we know that A comma B belongs to R, that is 1 comma 3 is belonging to R, but 3 comma 1 does not belongs to R. Hence it is not a symmetric. It is not a symmetric. Next, transitive. How do you prove for transitive? Transitive is, what does it says for transitive? A comma B belongs to R, then B comma C should be belonging to R. So this implies A comma C also should belongs to R. So what are the R condition? If I take A is equal to 1 comma 3, now so with the reference of B element, you need to check the C element. So A comma B is 1 comma 3. According to my condition, I have taken A comma B has 1 comma 3. It is belonging to R. Now check it for B comma C. Any B are there? Here the element is there. B comma C. So C element is 9. Is 1 comma 9 is present? No. Why it has to be present? According to the given condition, A comma C should belongs to R. So therefore, here symmetric conditions fails. So A comma B belongs to R, B comma C belongs to R, A comma C belongs to R. So what is the two conditions I have been taken? According to these two conditions, we know that 1 comma 3 is belonging to R. Next, 3 comma 9 is belonging to R, but 1 comma 9 does not belongs to R. Hence hence it is not a transitive. It is not a transitive. This shows how you have to prove for all the three relations with their conditions, how you have to prove. So let us go for the next second question. So according to the second questions, let us see what does it says. So the second condition says for the relation R in the set n of natural numbers defined as R is equal to y is equal to x plus 5 and x is less than 4. They have been already given x is less than 4 means what are the elements of x I can apply here? X is equal to 1, 2 and 3. X elements is 1, 2, 3 I can apply. So it is a set of natural numbers, means what? The relation is taking from n to n, set of natural numbers to natural numbers. Means if you apply any numbers for the value of x, the value of y is dependent on the n values. According to this, so let us check the reflexive condition. So what does the reflexive says? Reflexive says, so before that let us see R values. What are the R values? So if I apply x equals to 1, so what is the resultant of y will be 6. If I apply x is equal to 2, the resultant will be 5 plus 2 is 7. If I apply x equals to 3, the resultant is 8. So these are the sets of relation R. So in that you have to check it is a reflexive or not. So according to the reflexive, what does it say? The same condition a comma a should belongs to R. Is there any presence of a comma a? The same replication of the elements? No. So therefore a comma a does not belongs to R for every a belongs to a, hence it is not a reflexive. In a short form you can write it. As you know, the previously we have did the entire details of the reflexive, symmetric and transitive conditions, right? So now in the same way let us check for symmetric. So what does the symmetric condition says according to the R? So if a comma b 1 comma 6 is belonging to R, you need to check the reciprocal of these two or vice versa of these two. Is there any presence of 6 comma 1? No. So therefore a comma b belongs to R. This implies 1 comma 6 belongs to R, but b comma a does not belongs to R. So this means what? 6 comma 1 is not belonging to R. Hence it is not a symmetric. Hence it is not a symmetric. It is not a symmetric. Next, what is the third condition we need to prove? The third condition is transitive condition. So what is the transitive condition says? You need to check for three conditions. So transitive condition says a comma b belongs to R. Suppose if I take any elements in R, what are the R element here? 1, 6, 2, 7, 3, 8. So let us check. Is 1, 6 is belonging to R? Yes. 1, 6 is belonging to R. 1, 6 is belonging to R. Is there any presence of linked with the elements of B element here? 6, 8, no 6, 7, nothing is there. So you can directly write it as this implies B, C does not belongs to R. So this implies A, C also does not belongs to R. Hence it is not a transitive. Hence it is not a transitive. Hence it is not a transitive conditions. Next, let us go for the third problem. So what does the third problem says? According to the third problem, it says that relation R in the set A is equal to 1, 2, 3, 4, 5, 6. It is defined by the condition. It is defined as by x comma y is completely divisible by x. Y is divided by x means that is the relation is taking from the set A to set A itself. Means what? A cross A. R is equal to A cross A. So, how you have to check? So, the R condition states that y is completely divisible by x. Completely divisible by x means all the elements are divisible by itself. Means what? It has its own reflexive. Now, is that possible? 2 divides the value of 1? Yes. Can we prove for 2 divides the value of 3? No. Again, 2 can be divisible by 4, but it gives an half, that is, which is not a natural number. Next, again, 2 can be not be divisible by 5. No. 2 cannot be divisible by 6. So, according to this, while taking on, so we can say that according to the given conditions, so let us find the values of R. R is equal to, as I previously told, 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6 can be present, that is having its own reflexive. Now you check the elements. If I put y is equal to 1 and divide and vary with the elements of x, is it possible? No. Apart from that, after 1, you put for y is equal to 2. 2 divides the value of 1 is 2 comma 1 is present. 2 comma 1. Next, 2 comma 2 can be done. 2 comma 3 it is not. 2 comma 4 also it is not. 2 comma 5 is also not. 2 comma 6 no. That is x value is 2, y value is 1. No, that is also not possible. That is 1 comma 2 is present but not 2 comma 1. Next is the values of 2 comma 2 can be done. Next, y is equal to 2 and 2 by 3? No, that is also not possible. 2 by 4? No. 2 by 5? No. 2 by 6 also not possible. Again, check it for 3. Retain one element as constant and vary with the other element. So that is 1 comma 3 is possible. Again, 3 by 2? No. 3 by 4? No. 3 by 5? No. 3 by 6? No. Again, 4 by 1, that is 1 comma 4 is possible. Again 1 comma 5 is possible. Again 1 comma 6 is possible. Next, check it out. 1 comma, that is 4 by 1, yes, possible. Next, 4 by 2, that is also possible. 4 by 2 is possible. Next, 4 by 3, no. 4 by 5, no. 4 by 6 also no. Next, check it out. 5 by 1, it is possible. Again, 5 by 2, no. 5 by 3, no. 5 by 4, no. 5 by 5 is, yes, possible. 5 by 6 is also no. Next, check it for 6. 6 by 2, yes, that is 2 comma 6 is possible. Next, 6 by 3, yes, that is 3 comma 6 is possible. 3 comma 3 by 4, that is 6 by 3, yes, possible. Again 6 by 4, no. 6 by 5, no. 6 by 6 also, no. So these are the elements of R element what you have been got. So according to this, you need to check whether it is reflexive or transitive or symmetric. So the reflexive condition says, so what does the reflexive condition says? A comma A should be present for every A. So how many elements are there in A? 6 elements. Has its own reflexive? Yes. 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. So each and every element is there. So A comma A belongs to R for every A belongs to A. Hence it is reflexive. Next, check for symmetric. Is that possible? For the symmetric conditions. So what is the condition here? A comma B belongs to R. So this implies, let us check any kind of 2 elements. So I will take the elements of 1 and 6. So if I take 1 comma 6, is there any presence of 6 comma 1? No. So 6 comma 1 it is not possible. That is 1 comma 6 belongs to R. But B comma A does not belongs to R. Therefore 6 comma 1 does not belongs to R. Hence it is not a symmetric. It is not a symmetric. In the same way, let us check for transitive. What does the transitive condition says here? Again, you take any kind of 2 elements. If I take 1 comma 2, this 2 has to be linked with any kind of elements. Is there any present? 1 comma 2 is there. 2 comma 6 is there. Is there any presence of 1 comma 6? Yes. 1 comma 6 also it is belonging. So according to this transitive condition, what does it says? A comma B belongs to R. If I take the elements of 1 comma 2 belongs to R. Next, what is the B condition? B has to be linked with C. That is B comma C should also belongs to R. So this implies was 2 comma 6 is belonging to R. Next, again the third condition is A comma C should belongs to R. So this implies 1 comma 6 should belongs to R. Hence it is transitive. It is transitive. The possible is there. Transitive condition is there. So the next question is fourth one. So what does this say is the fourth one values? As you know, the relation R in the set of all integers, set A from A minus x minus y is an integer. So as it comes to an integer, what does it says? For every integer, either you divide, either you multiply, either you add or either you subtract. It always gives an what kind of condition? Integer only. For example, let us check. So in Z, what are the elements will be there? 0, plus or minus of 1, plus or minus of 2, plus or minus of 3, again plus or minus of 4 up to so on. That is it includes both negative and positive integers. So what is the condition here? It says that x minus 1. Suppose if I take x is equal to 8 and y is equal to minus 1. So let us check whether it belongs. So 8 minus of minus 1, which gives the value of 9. Is it true? Is this 9 is belonging to the Z? Yes, it does. Now let us check for the similar elements. X is equal to 2 and y is equals to 2. So what are the elements here? What is the condition? X minus y equals to 2 minus 2 is equal to 0. Does 0 is belonging to the Z? Yes, it belongs. So what I'm trying to say is, for every element, whether it is a subtraction, it gives the same integer value. It gives the same integer value. So for the reflexive condition, I have been given an example, that is 2 and 2. If I take and deduct with the same condition, it gives 0. 0 belongs to what kind of set? It is an integer sets. So what does it say? For every elements of the reflexive conditions, it shows a reflexive condition for the integers. So you can directly write it as reflexive. For reflexive, that is A comma A belongs to R, hence it is reflexive condition. It is a reflexive. So if you want an example, you can take any kind of element. So 0 minus 0 belongs to R. So 0 belongs to R. So it is a reflexive condition. Next, when it comes to symmetric conditions, so same condition, symmetric. So what does it says? A comma B belongs to R. So you can take any kind of element, that is -1 and +3 belongs to R. So for the given elements, it belongs to, that is B comma A also belongs to R. That is 3 comma -1 also belongs to R. So therefore, hence it is symmetric. The possible is there, symmetric. Next is transitive. So what does the transitive condition says here? Transitive says has. Transitive, same condition you can apply. So according to the transitive here, if A1 comma A2 belongs to R, then A2 comma A3 belongs to R. If both the belongs to the integers of Z, so we can say it has A1 comma A3 also belongs to R. That is A1 comma A2 comma A3 belongs to the set of Z, hence it is transitive. Hence it is transitive. Condition proves here.